let me start by, when you look at the energy usage of commercial buildings, the reason we're talking about lighting right now is that lighting accounts for about a third of the energy in commercial buildings throughout the United States. So it's one of the, if not the, it's very close, is one of the very largest consumers of our electrical energy in this country. Let me do this. I'll spend just a minute on optoelectronics, and then what I'd like to do is touch base on the market, the lighting market, that is, some of the challenges in converting, basically going through this adoption change, this transition from the old traditional lighting technologies to solid state lighting, and then some of the opportunities that these challenges really bring to a lot of people in this room and to the entire industry. Optoelectronics is a company that designs and manufactures very high quality solid state lighting products. And solid state is a term that's used interchangeably with, we use LED technology to build those. The company was actually founded by much of the senior management out of Siemens, which is where I think I did hire. I don't know if I ever fired you, but I know I hired you about at least 2 or 3 times there.
Hired me twice, thank you.
And so the founders of their company all have, we each have about 30 years and $3 billion of experience in the LED technology area. What we do today is really work at accelerating the adoption of solid state lighting technology. We're doing this in both the commercial and the residential consumer application areas. We do this in 2 product categories. One is we build very highly engineered, fully integrated solid state light sources. They include everything. So all you do is you connect your voltage to it and you get light out. Those we sell primarily to OEMs, large lighting companies such as Philips Lighting, for example, Electrolux, and so forth. So they buy these light engines from us and they literally just simply slide them into their mechanical packages. They're in products which you see when you see a lighting fixture. It enables them very quickly, without having in-house all of the engineering capabilities that we do, the ability to adapt solid state lighting, in many cases to fixtures that they've sold for decades with older technologies. We also have a new area that we've entered in this last year, which is building fixtures themselves, and specifically in the very high output fixture area. These are high bay, low bay lights, lights for at the low end for illuminating parking lots, parking structures, and at the high end for doing things like lighting the interior of a FedEx warehouse or a First Solar factory. Those are some examples of some of the projects that we're involved in. So let me jump to the market.
So Chuck, let me interrupt for a second. You build the semiconductor chip itself, right? You do fabricate the
No, we don't. The chip itself, the LEDs, which is what we did for many, many years, have really become a commodity today. The LED guys, and I'm an old LED guy, I don't like to hear me say that, but the fact of the matter is every one of our products we build and we can use virtually anybody's LED components in there, just like you can use anybody's resistors or capacitors. The LED components themselves have really, truly gotten to a point where they are a commodity.
So you're taking the LED chips, these commodities, and the innovation is in the packaging of
That's
these
right.
LEDs. Okay.
We purchase the LED components. A typical product will have 50 to 100 line items on our bill of material. One of those line items will be the LEDs. The products are fully enclosed. The packages are both industrial designed and thermally designed, usually using aluminum materials for the thermal properties. The electronics in them include not only the power for the LEDs, but quite an extensive amount of control electronics. And as we touched on earlier, control is a very, very important aspect for a whole bunch of reasons. So, what I tell our own employees today is we're no longer building just a simple LED product. We're building very complex, very reliable, which is very important, electronic products with a lot of bills, a lot of items.
So we're all familiar with lights. Are you selling it to a Philips and Osram that they incorporated into a Edison type bulb, or is it? So what is the end product that it
That's-
typically ends up at?
That's a very good question, and that's a very fundamental question. We are doing products like a T8, replacement bulb, but our primary focus is really on doing permanent light sources. When we work with the major lighting fixture companies, and this is touching on some of the disruption that's about to take place, is the fact that the concept of a screw-in light bulb, a replaceable light bulb, is going to be very similar to what I remember, the way I remember a rotary dial telephone or tubes in my radios, when I was a kid. The function of the socket is, the only reason the sockets are there is because the older incumbent lighting technologies we've used, they go dark, they burn out, and they burn out in a relatively short period of time. With the solid-state lighting technology, if the product is designed properly, the light source will be a permanent part of the fixture. And it'll last the life of the building, or your home, or your lamp fixture. You'll be able to hand it down to the next generation, it'll work just fine. So suddenly, you don't want to invest in people that build light bulb sockets. That's not a growing market at this point. Just some points about the market, though, that I want you to think about tonight is when you look around the light fixtures in your home or your office. First of all, the lighting fixture industry it's very large. It's $60–70 billion a year, but it's extremely fragmented. And sitting here in the middle of Silicon Valley, for those of us that have worked in semiconductors for many decades, to give you an idea of how fragmented it is, there are over 1,500 lighting fixture companies just in North America. Half of that market, the lighting fixture market, is provided by 4 companies, people like Philips Lighting and Cooper Lighting and Hubble and so forth. At Philips Lighting, any of these big guys, they'll have 500,000 SKUs of lighting fixtures. Their definition of high volume is 3,000 to 5,000 units per SKU per year. So you start thinking about that, and also start thinking about the fact that when you buy a lighting product, you buy the fixture from any one of 1,000 or more different possible channels. You buy the light bulbs from just one channel at your local hardware store. And it isn't until you buy both of those products and you put them together, whether it's here in this building or at your home, that you have what we refer to as a luminaire. It's a fixture that puts out light. So now start thinking about that conceptually in the industry. So we have an industry of lighting fixtures which contain nothing more than metal, glass, a socket, 2 wires, and a plug. The last technology shift, major change, the people that make those products, was when we went from kerosene to electricity. So there's nobody alive today in the lighting fixture industry that was around that. Then you have us characters coming out of the semiconductor industry where, we wake up 3 times a night worrying about our competition coming out with some new breakthrough before we wake up the next morning. It is a huge, huge gap between the technology worlds of solid-state lighting, which is projected to be the dominant light source moving forward here very soon, and the lighting fixture.
Chuck, I've waited 20 years. I'm cutting you off.
All right, good.
So but it's you said a $70 or $80 billion market. I've heard $100 billion.
Well, the $100 billion
is the luminaire market.
There's about, it depends on whose figures you use. At $100 billion, 20 of that is the light bulbs, which come from 3 guys in the world, and the other $80 billion comes from thousands of people.
But that industry is flipping. It's finally happening, right? It's a done deal. It's going LED. It's just a matter of how it happens, channels, and when. We have to talk to Matt. Matt, so you're at IBM. You handle buildings. That's your area. You can talk about lighting, or you can talk about IBM's take on buildings.
Yeah, I think maybe, lighting is clearly one of the most important parts of buildings, but we again certainly take a broader look at it. We've actually been in the greener or smarter buildings area for quite some time, about 15 years or so. But just recently, because of what's been going on, we've formed a very focused business in the area, bringing everything together. Now, all the kind of things you need to do in a building, we only do a tiny fraction of them. So we often take a role as a general contractor, do the things that we can do, and then we bring in partners to do all the other things. So we'd be partnering with companies like Optical Electronics that had some of these engagements. Now, so we course, because just like we mentioned before, enormous potential for energy savings. You know, buildings, the non-industrial buildings, it's about 40% of energy usage, at least in the developed countries. Estimates, we have a typical estimate of what you can get from making a building smarter is about 40% energy savings. So that translates into 16, if you did that to all buildings, 16% reduction in energy use, total energy use globally. That's an enormous amount, dwarfing anything you're expecting from renewables and so forth. That's kind of the meaning behind us being the Saudi Arabia of energy efficiency. So enormous potential there. Water reduction is about 30% in a smarter building. And even things you don't count on initially, employee productivity. A lot of studies on that. Sometimes it's hard to measure, but typical estimates range around 20% employee productivity increase from having a greener building. So there's an enormous value in doing that. There's kind of three tacks you can take on it. The one is you can just make the equipment fundamentally more efficient. So that's like LED lighting opposed to regular, or there's a newer HVAC system that's just better. That's one way to do it. The other one is and you only get a chance to do this once, except around the edges, but is a better building design. There's less of that in the U.S. and in the developed countries because we've built most of our buildings. You can do a little retrofitting, but it's hard to change design much. But in places where they're building new buildings, fundamentally you can design it better, to use more natural light, fundamentally position things better relative to the sun and so forth. And then the other one, the one that we really focus on, is this making things more intelligent. So the way that you manage having everything instrumented and pulled together. So these pieces of equipment, they're often running suboptimally, and that could it can double the amount of an HVAC system that's out of tune, using double the energy that it should be using. And that's about equivalent to lighting in terms of the amount of energy that it takes in the building. So just being able to instrument things, analyze them, do analytics on them, see when something's detuned, ideally remotely fix it, but if not, even send a person there, enormous savings. And even managing things, preventing stupid things like having the air conditioning competing with the heating and some of it. And that stuff goes on a lot. So just having sensors, instrumentation, the census kind of stuff can go a long way. I think just as far as the trend that is probably the most interesting trend for the Valley here in buildings is the trend of a kind of a convergence of what some people call operational technology, or the more engineering-oriented technology, with traditional IT, the way probably most of us see it here. Traditionally, buildings are the building management systems. They're these proprietary systems built by the controls companies, and if you want to change something, you have to get one of them in to write custom code on a custom operating system with things that no one knows about. So it's very hard for entrepreneurs to break in, and I've talked to a lot of venture capitalists in this area who would love to get into this market. They love the market, they love it, but they see it as closed, and they don't know they can get in. So even the building controls companies, they all say it's going to go to IT and open standards and interfaces, but some will say 2 years, some will say 10 years, some will say this is the debate there, but it seems to be going faster than most people expect. And if that happens, you'll have standards, you'll have open interfaces, and there'll be lots of opportunities for smaller companies to come and do innovative things that can manage the building. So I think that's the key to watch, how open these systems become.
Don, you have a question about lighting or buildings?
Yeah, first of all, I totally support this point on a general move towards the IT-ification, if you will, of facilities and facility systems. The old Venus and Mars analogy. I mean, facilities and IT have been separate universes historically, and you're starting to see them come together with a lot of these technologies. And it represents a big challenge for providers trying to serve this space. You know, do you sell to the facilities person? Do you sell to the IT person? You go to your facilities guy and say, I need access to the corporate network. Well, you know, facilities doesn't often get that. So anyway, I guess I'd come back though to a question, and I've heard this from some, you know, system designers of lighting systems and that the sort of thing. Not an expert in this space personally, but I thought it was an interesting question, which is, okay, it costs money to go put new lights in. You know, what's the relative performance of a solid state, you know, replacement for a fluorescent tube? I mean, fluorescent tubes are reasonably efficient. You know, a solid state that much better. It's better, I understand, but how much better? And does it justify ripping out the old ones and putting in the new ones? Or do you wait for when these, you know, are logically going to be replaced anyway, and then put in a whole new fixture? Because your point on the fixture and the light source being integrated, I think, is a really interesting one.
So what is, Chuck, I mean, you don't sell these luminaires to the buildings themselves. That's not your business. You have to go through that horrible fragmented channel that you're dealing with, right? But
that's true, except for our high output fixtures in there. We sell through organizations like ESCO's channels where
Okay.
we're actually selling. We've got a pretty direct contact to the end user.
Okay, so what do you see the adoption mechanism looking like? Is it replacement? How does EMC get rid of fluorescent bulbs if LEDs are in fact much more efficient?
Well, I think this is part of the element of the disruption of the technology. We're going to go through a period here where you'll have a lot of people building replacement bulbs with the technology, and that's simply because they have fixtures here.
Legacy fixtures.
And that'll happen until the cost and efficiency of replacing them with a fully integrated product makes more sense.
And are you adding more? You mentioned, we talked a little bit about controls. There are a bunch of venture capital funded startups, Redwood Systems, who are adding some intelligence into the fixture itself. Are you looking at that?
We're, from our view and working with the lighting fixture guys, the lighting fixture guys are so far behind in terms of understanding things like control technology that what they don't understand is we can take one of our products that has all this electronics already in it. For literally a few pennies, we can add occupancy sensing, daylight harvesting, all these things.
Addressability.
And this is part of the transition. Is you're dealing with a huge industry that thinks very slowly, moves very slowly, and they don't really have an appreciation yet for what we can do from a technology standpoint. So we can go much farther ahead with the control aspect of it than we see any customers that actually understand that.
Questions from the audience? Jonathan, please.
So this is an area I really enjoy hearing about, and I enjoy your remarks very much. One of the holy grail items that you address, I think conceptually, I'd like to talk about quantitatively, is the life of the LED. The nominal life that's generally accepted is 50,000 hours, and for comparison, the life of an incandescent light, like I have in my old desk lamp, is 1,000 hours. I'm getting 50 times longer life. If that bulb gets replaced once a year now, it'll get replaced in 50 years when I go to LED. But there is a next step, and that's 100,000 hours for LEDs. That's been claimed and talked about. But how do you test that? How do you prove something where it's going to take 10 years to show that it's right or wrong? Even I'd like your thoughts on that.
You asked about 3 questions here. First of all, the way you prove it is the same way we've been doing it in the semiconductor world with chips, with microcontrollers and processors and so forth. You run through the product with very elaborate, careful reliability tests and qualification tests. It starts, though, with the design of the product. And the LED itself, this is one of your other questions, is the lifetime of an LED, you have to, here's another part of the disruption. Everybody in this room thinks that light bulbs burn out. They go dark. LEDs never go dark. They don't go dark. What they do is they very slowly lose some of their efficiency. And so the way that the industry over the last 10 or 15 years has come up with a way to kind of relate to the layperson on what lifetime is that typically we'll talk about what's called the L70 point. That's the point where the light output is about 70% of its original output. Keep in mind that the human eye, for most people, they won't see it until it drops about 50%. And so the LEDs themselves actually are not the limiting item today. The LEDs will last 100,000 hours, 50, 75, 100,000. The limitation is, I've mentioned the 50 line items on the bill of material. The LEDs are one. It's the other 49 items on there. So it's you see a lot of LED products now. They'll put in capacitors that don't have greater than 2,000 hour operating life. Well, you've just defeated the whole purpose of the whole technology. So yeah, we put in a lot of thought into the electronic design.
We'll take one more question, sir.
I want to ask the audience here, by show of hand, how many of you have driven by with these LED lights, traffic lights, and seen half the bulbs gone?
No way. Yes?
Yeah, and that's not the LED that's failed.
For me, it's failed.
Yeah. No, but it gets back to his point, and my point, and that is, it's the reliability of the electronics in there. The LEDs are perfectly fine, it's just that there's a bad solder joint in there someplace. And that's why in our case, we put 80% of our effort, all has to do with the reliability of the electronics.
You know,
So when
obviously, we
when
can
there
go
is a-
out on
right.
lighting for
Yeah.
a long time, and it's
Sure.
a subject dear to my heart. We'll take one more question. Sir, you had a question.
Yeah, so one of the questions or challenges in LED lighting is the heat dissipation. And typically you're using heat sinks and other methods. What are the technologies that you're looking at? And second, can you use that heat that's coming out to further feed energy to the LED and reduce your energy consumption? It cannot be much, but are you looking at that technology?
Absolutely.
And I have to say Eric is not as bad as he says he is. He gave me a chance to answer the question.
Let me answer that question, and I'll stick around after the meeting. If anybody else has any questions.
There's gonna be breakouts after the meeting, right? So we're gonna,
Okay. Okay, so what was your question? The,
The heat.
oh, the harvesting heat. We need to come up with a different term than heat in the LED industry. We have the same heat issue that an Intel microprocessor has. I used to be a quality engineer manager at Intel. So it's not heat in the sense that it's going to warm up anything. It is heat in the sense that at the junction of the semiconductor material of the LEDs, you want to control that so that it doesn't hit a point where it actually starts shortening the lifetime of the operating lifetime of the LED. What we do in all of our products is we put in what we call active thermal foldback. So every product we ship has, it actually measures the temperature for the life of that product. It measures the temperature at a certain point on the LED that the LED manufacturer specifies. We feed that signal back real time, and it goes back into some of our control circuitry. And best example I can think of is if somebody took a light fixture, put it on a south-facing wall in Phoenix in the summer and left it on all day and it's 120 degrees out, our product will limit the current. It'll slowly decrease the drive current of the LEDs.
but to address your question, you're talking about heat harvesting, which is a viable sector, and people are looking at it. We waste a lot. We're the Saudi Arabia of heat wastage as well, but I don't think that's applicable exactly to.
Yeah, we look at it the other way around. If you look at this building, a certain amount of the air conditioning is spent to remove the heat that's generated by the lights. And depending on the lighting technology, it can be a lot. So with the solid state lighting technology, you don't have that issue. It's not putting off that ambient heat that you would feel with any other light.
All right. So Chuck is obviously a